Hey, we have an interesting integral on the board. We have the integral of 4 over the square root of x to the 2/3 plus x squared dx. You could try to factor out an x squared from the denominator, but it's actually going to work better the other way. If we factor out x to the 2/3, it's going to set up a u substitution more nicely because we're going to have a fraction exponent in the denominator and in the numerator. So let's start there. We'll rewrite this. I'm going to write the 4 outside the integral because that doesn't do anything for us. Then we'll factor out x 2/3. But notice we can write this 2 as 6 over 3. So that's going to make when we factor this, this will be a 1, and then this is going to be x to the 4/3, right? Because 2/3 plus 4/3 is 6/3, or 2. Then next we can pull this outside of the radical. So the square root of x 2/3 is going to be just x to the 1/3. But then we can move this to the numerator. So this in the numerator is going to be x to the minus 1/3. And when I did this problem this morning, this is the step where I got in trouble. So what I wanted to do, what I did was I decided to make this my u. So let's try that. We call u 1 plus x to the 4/3. Then we get the derivative du, and that's going to be 1. Derivative of 1 is 0. Derivative of x to the 4/3 is 4/3 x 1/3. And then I was like, why is that 1/3 and that's negative 1/3? It doesn't make any sense. It doesn't work, right? We can't use that as our substitution. I scrapped this. So then just looking at this numerator and what we need in order for this u substitution to work, we would want u equal to x to the 2/3. Because then if we do our derivative here, du, on this we get 2/3 x to the minus 1/3 dx. And that's gonna work nicely. We can make this happen, and then you also notice what we have in the denominator is not that bad. We don't have a 2/3, but we could create that. We can write our x to the 4/3 as x to the 2/3 squared is x to the 4/3. And then so this is going to be our u squared. Before we do our substitution, let's just get the numerator to look exactly like our du. We can write in a 2/3, but then we're changing the expression, so we'll write a 3/2 in front. Now we can substitute. So 3/2 times 4 is going to be 6 outside the integral. I think this pen's getting dry. All right, let's go. So next we'll notice our whole numerator is just our du, so we'll write that in. Same thing as this. Then in our denominator, we're going to have 1 plus, and so we already said this piece here is actually u squared. From here, we could actually do a trig substitution, probably substituting tan in for u, but this is actually a well-known integral, and so we have a solution for this, and it's actually going to be sinh hyperbolic sine, but the inverse of that, plus c. So then all we need to do now is our back substitution. So we have our u value. Let's bring it back in for u. And then for our final answer, we're going to have 6 sinh hyperbolic sine inverse x to the 2/3 plus c. And that's going to be our solution. Got this problem from my quiz, integrals with roots. I'll provide a link in the description. Hope that helped. Thank you.